All right, so we got to the point where we took the first derivative and we're setting it equal to 0 because we want to minimize the total cost. So I'm going to add this to both sides, and I get 90 equals 195,000. I'm going to move that x squared in the denominator. And now I'll cross multiply. So x squared equals 195,000 divided by 90, which is 2.66967. Now if I take the square root, normally you would take the square root and get a positive and negative 46.55. But since this is a length, the only one we care about is the positive. Now, so that's how I did it. I took the square root of this number. And then once I had x, I could figure out y, because y equals 3,000 divided by x, and that's 64.45 feet. All right, now the question asked, find the minimum total cost. So I go back to the cost function, and I plug in what I have for x and y. 45 times 2 times x, 46.55, plus y, 64.45, right? Plus 20 times y, 64.45. All right, so the minimum total cost is $83.78.75. So it's always important to go back and make sure you're answering the question that they asked. Okay? All right. Again, find the global max and min. Now we're on an interval from -3 up to 1, right? So take the first derivative, which is 4x to the third minus 16x. Set it equal to 0. Well, I'm able to factor out a 4x, which leaves me x squared minus 4. Guess what? Again, we have difference of perfect squares, x minus 2, x plus 2. So x equals 0, x equals 2, or x equals -2. Notice in our interval, right here, the 0 works, the -2 works, but this one doesn't, so we don't need to worry about that one. So I need to find out if they're maxes or mins, right? So I'm coming over here, and I'm going to take, I could do it different ways, right? I could say, I'm going to take 0 and -2 and figure out what's going on maxes and mins, but I also need to check the endpoints when I have these intervals. So instead, I'm going to go back to the original function, and I'm going to check the values at 2 and 0, which are my max and min. One of them or the other, I don't know. I'm going to check at -3. I'm going to check at 1 because those are my endpoints, right? So if I did this right, I plugged in -3 to the original function. That would have been, I believe, 9, but I'm going to try it just to be sure. Yes, I do believe I did this. -3 to the fourth, this is 81 minus, -3 squared is 9, minus 72. So this value is 9 right here. When I plugged in -2 into the same, I got -16. 0, notice I get a 0. And at 1, I plug it in, I get a -7. So I like to kind of see what's going on. Here I have from -3 to 1, I'm at 9. I go down to -16. At 0, I'm at 0. And then I'm down to -7. So notice that my global min is right here, which is -2, -16. And this one here isn't global because this endpoint is higher. So my global minimum is this, and my global max, because that's what they're asking for, global, is at -3.9. This one indeed is local, but it's not global. All right? Determine the critical points of f. They're giving you all these values, so you don't have to take the derivatives actually, but we want to find the critical points and then classify them. So I'm going to use the first derivative, and what you want to notice is that denominator is always positive. So if you're trying to set this equal to 0 and figure out when it equals 0, you have to look just at the numerator, and what you'll find is at x equals plus or minus 1, those are going to be our critical points. So let's figure out if they're maximum, minimum, or neither. It doesn't give us a, these will be local. I think from negative infinity to infinity is our interval here, right? So I'm going to look at the points, these 2 points, and see if we're concave up or down. So I'm going to use that second derivative. 2x to the third minus 6x over x squared plus 1 to the third. Now again, that denominator, x squared, is always 0 or positive plus 1. So this thing is always positive. So I will look at the numerator again, and I'll set that equal to 0, right? So if I set that equal to 0, or actually I'm not finding inflection points, so I don't need to set it equal to 0. What I need to do is figure out what f double prime of x is sign-wise. So at positive 1, this would be 2 times 1 minus 6 times 1. Okay, that's negative. That means it's concave down, right? And then this x equals 1 is a maximum, isn't it? Let's test. I'm going to come up here. Let's test x equals negative 1. It'll be 2 times negative 1 minus 6 negative 1, which is negative 2 plus 6 is positive. This is concave up. So this is, oh, I'm sorry, concave down. Concave down means maximum. Concave up means minimum. All right? We didn't have any neither in this particular problem. It says compute the limit of this. I believe we have to again look at, use L'Hopital's rule, because right now this is 0 over 0. So if I take the derivative of the top, I get 2x. The derivative of the bottom, the derivative of negative cosine, derivative of cosine is negative sine, so that means negative cosine is sine. Alright, if I put 0 in here, 0 over 0, it's indeterminate. I have to do it one more time. Derivative of the top is 2. Derivative of sine is cosine. So now if I take that and I compute the limit as x goes to 0, this is 2. The cosine of 0 is 1. It's 2. Alright. We're going to use our linear approximation again, right? Which is f of a plus f prime of a times x minus a. Okay, use it at x equals 3 and estimate 4. So let's first fill in. So our linear approximation is going to be f of a, which f of 3, they tell us that's 5, plus f prime of 3, which is negative 2, times x minus 3. Now we're going to figure out what we have if we try to figure out at 4. Right? 5 plus negative 2, 4 minus 3, 4 minus 3 is 1, 5 minus 2 equals 3. Okay? Because this, if I check my, if I know that this is always concave up, my tangent lines are below, which means I underestimated. Okay? It's a good thing to remember. If it's concave up, I'm underestimating because my tangent lines are below. If it's concave down, I'm overestimating because my tangent lines are above. Alright, I think we have everything for sample number 4. Please look this over and see what kind of questions you have. Alright?